Okay, so in this 5-number summary in the box and whisker plot, we've got 5 points. We've got one here at the far left end. We've got one at the left end of the box. We've got one that's going somewhere through the middle of the box. We've got one at the right end of the box, and then we've got one all the way to the right that's making like the other end point of what's called the whisker there. So the one on the far left here is called the lower extreme. So the lower extreme is just a fancy name for the minimum. It's going to be the smallest data point in your set of data. So pretend, and I've got a set written up here on the board. Actually, I'm going to draw or erase these, and we'll add these in a second. Okay, so let's pretend that I've got this data set. 1, 6, 9, 10, 11, 12, 13, 15, 16, 17, 17, 18. No idea what this data represents. But my lower extreme would be the 1 because it's the minimum value here. Okay. My next data point, the one that makes the left edge of the box, is called the lower quartile. Okay, so I'm going to read you the definition, then I'm going to explain how you would find this. It says it's the value of the median of the lower 50% of the data, where 25% of the values are smaller than the lower quartile and 75% are greater. In other words, the lower quartile is the median of the lower 50% of the data. Okay, so before I kind of go through and explain that, okay, this is the lower quartile, but this line that's going through the box is actually just the median. Okay, so we've already found median. You know how to find the median. You line them up, you cross till you get to the middle. So this is the minimum. Here is the median. This lower quartile is looking at, okay, if this is the median, I'm going to look at just the data that falls in this first half, the lower half before the median, and I'm going to find the median of that set of the data, and that's what the lower quartile is. So it's like I'm finding the median of the bottom half of the data. Okay? I'm going to go back to that 25% number in a second. So then the line that's on the right-hand side of the box is the upper quartile, and that's the opposite of the lower quartile. It's the median of the upper half of the data, okay? So we're essentially finding the median, and then we're finding the median of the bottom half and finding the median of the upper half. And what that does is it splits our data into 4 equal sections, or 25% of the data falls into each section, okay? Now, what's tricky, and this will show up on the last slide here. Actually, I'll tell you what's tricky in a second. The interquartile range. So this, I think, is the term that showed up on your state test, which we didn't talk about before testing. So the interquartile range is the difference of the third and the first quartile. So it's just the range of that middle section of data rather than the entire range. So I would figure out whatever my upper quartile is, figure out my lower quartile, and the range of that is the interquartile range. Okay? Our final point is called the upper extreme, which is the maximum, okay? And that's the highest data point. So at the bottom of this slide, it gives us a kind of reminder, and this is what's kind of tricky to wrap your head around. It says, even though the horizontal sections of the box plot are different lengths, each section represents a quarter of the data. So what I mean by that is that this box and whisker plot is splitting our data into 4 parts. We've got one section here, one section here, one section here, and one section here. Each of those sections represents 25% of the data, okay? So in our heads, it feels like, well, if each section represents 25%, each of those sections should be the same length. But they're not. That whisker on the left is a lot longer, and then my second section is really short. And a lot of people are like, well, that doesn't make sense. So if I put numbers to it, so that's what I have written up here on the board. Let's pretend this is what the data represents. Essentially, here's my median. Here's my median of the lower half. So we've got, this is the first whisker, second section, third section, and this is my other whisker. Looking at the numbers I have written on the board, is there anyone who can make an observation as to why that bit, the first whisker, the one on the left, if it represents these numbers, 1, 6, 9, is a lot longer than the first section of the box, which represents 10, 11, 12. Gus?
Because 1, 6, and 9 are much lower numbers than 10, 11, and 12.
They are lower, but that's not why the section is longer. That's a good observation, though.
Because the median is lower than the median of the...
No, Blake?
Well, the first one goes all the way up to 9 on the second one. And it, so 1 to 9, 9, and then the next one, 10 to 12, so it's only
Yeah, so it all has to do with the spread of the data or the variability in that section. So if I'm looking at this section right here, the first whisker represents 1 through 9, which is a spread of 9. But the first section of the box represents 10, 11, 12. That's only, those numbers are a lot closer together. So depending on how close or how far spread out the data is in that section, that determines the length of that section of the box and whisker plot. But know that each section represents the same amount of data. So this is what my box and whisker would look like here. Okay, so these 3 numbers fall in my first whisker. These 3, next section. These 3. So it's the same amount of data in each section, but they're different lengths in each section because of how far spread out or how close together the data is. Okay, so each of these represent 25% of the data points. All right, so we're gonna look at a couple of box and whisker plots, and then we're gonna practice making a couple. And then once we do that, you'll have time to start your homework. All right, so looking at this one, it's a box and whisker plot that's showing reading speed. One thing I should do is go back for a second. Box and whisker plots are probably a graph, I would guess, that none of you have seen before. Is that an accurate guess, other than when I previewed it a couple weeks ago? Okay. They are not a very common type of graph. You're honestly not going to see them much, but what they are good for, and what we're going to use them for here this week and next week, is to compare different populations or different things looking at the same data. So what we're going to do is we're going to collect data in your class, in class 1, and in class 7, and then we're going to make box and whisker plots for all 3 classes. And when you put those box and whisker plots all on the same number line, you can very easily tell where is the low score happening, where is the high score, who's got the most variability. So you can compare different data sets pretty easily by making box and whisker plots for each of those data sets. Okay. All right, so let's look at this one. It says use the box and whisker plot to answer the questions. What is the reading speed in the exact middle of the data? So thinking the median is what's the middle. So which speed would that be looking at this box and whisker plot? Which one represents the median reading speed or the middle? Ella? 190 is our median. That's the exact middle. Very good. Words per minute. How many words does the slowest reader read per minute? So find the slowest reader. Jonah, what do you have? That's right. 60. 60 is our minimum, and that's this point right here. Very good. How many words do the middle 50% of readers read per minute? So remember, each of these sections is 25%, 25%, 25%, and 25%. So I'm looking for the middle 50% read between this number and this number. What are those? Weston?
The middle 50% reads between 120 words per minute and 230 words per minute.
Excellent. So it's that box right here represents our middle section of data, middle 50%. The interquartile range would be the difference between those, so 230 minus 120. But yes, the middle 50% read between 120 and 230 words per minute. Good. Questions on it, how we got any of those answers? All right, let's look at another one. Same graph, but the question's different. How many words do the fastest 50% of readers read? So between what and what do the fastest Chase 50% read? I'm going to zoom in for you. Very good. 190 to 270 words per minute. Excellent. All right, these are different box and whisker plots now. Question here says, does the data set have an interquartile range of 16? So I'm going to phrase that differently. Which of those box and whisker plots has an interquartile range of 16? So the difference from the far edge of the box to the first edge of the box. Quartile, upper to lower quartile. Miriam?
B.
B, did you say? Okay, so finding our interquartile range, we're going to take this upper quartile, which here is at 20, and we're going to subtract our lower quartile. 20 minus 10 gives us an interquartile range of 10. So that one's not going to be quite 16. Pick a different one, Anaya. C. So if we look at our upper quartile is at 115. Our lower quartile is at 99. 115 minus 99 is 16. So that one does have an interquartile range of 16. What about the top one? What's the interquartile range of the top one? Not quite 15. It's close. 13. So from 55 to 42 is 13. So we're just subtracting this upper quartile and our lower quartile. Questions on that? All right, let's look at one more, and then we're going to practice one. So it says, which race was more competitive, this year's or last year's race? Tell how you know and provide possible reason for the difference in race results. So I've got two box and whisker plots here. We've got one showing this year's race and one showing last year's race. The question is asking which one is more competitive? Which one do you think and why? Weston?
I think the last year's car race was more competitive because it has higher dot points on the things and the range is higher.
Okay, so the range is higher and it's got higher speeds than last year's. Okay, Gus?
I would say this year's car race is more competitive for the reasoning of all of the ranges are closer together, meaning although they couldn't get higher speeds, they were still a bunch of people in the same area that are competing against each other.
Yeah, so think about if you're watching a race, whether it's a track race or a car race or a horse race, whatever it is, what makes a race competitive or exciting to watch? Anaya?
Everyone's close.
Yeah, the closer people are, or horses or cars or whatever, the closer the things are together, that's what makes the race exciting, right? Okay, so in this year's race, I would agree, it's going to be closer together because the speeds are closer together. In last year's race, it might have been really cool to see a car going 190 miles per hour, but is that going to be super competitive if I've got somebody going 190 at the same time somebody else is going 30? Probably not as exciting or as intense of a competition, right? So in this case, if we're looking at racing, the closer together, which it means the shorter the sections, the more exciting that race is going to be. Good.
30 miles per hour.
I would guess that maybe their car was not functioning correctly, if I were to guess.
They did it again. They're only going 40 in this.
Yeah. All right, so I'm going to pass out a paper and we're going to do this together. The paper I'm about to give you has notes on one side. So basically, it gives you step-by-step and all the definitions we just went through, I'm giving to you. So this is a paper you're not going to want to lose, and then we're going to practice on the back together. All right, so the very first step when making a box and whisker plot is going to be to take your data and to put it in order from least to greatest, because we're doing lots of medians here. So let's rewrite this in number 1 from least to greatest. So I've got a 5. I've got 18, I've got 20, 25 and 27, 35, 38, 40 and 48, 60 and 90. And you can see I crossed them out up top when I used them, so I knew which ones I was still looking for. All right, so then it says step 2. Now typically, and I should have whited it out before I copied it, but I didn't. The box is not going to be there to start with. Okay, that was kind of given to us. That's not going to be there. We're going to be starting from scratch. But the first thing would be to mark the extreme values on the box plot. So our upper extreme and our lower extreme are just our minimum and maximum. So we're going to put a dot at 5, and we're going to put a dot at 90. Those are our upper and lower extremes, the minimum and the maximum. Just put a dot. Once we confirm that that box is in the right spot, we'll draw those whiskers to connect them, but we'll leave them for now. After we've got those graphed, the next thing we need to do is find our median. So we're going to take our list and we're going to cross out till we get to the middle. So 5 and 90, 18 and 60, 20 and 48, 25 and 40, 27 and 38. So our median is 35. I landed exactly on one number. That's our median. So we're going to put a dot there as well. Once we confirm that box is where it's supposed to be, we'll draw a line there because it goes through the middle.
Isn't it supposed to be a line and not a dot?
So I just said once we confirm that the box is where it's supposed to be, then we'll draw that line in. Yes, for now, we're just putting it as a dot.
I thought it was always a vertical line.
It will be a vertical
Box
line?
won't always be there.
Yeah. So we're pretending that the box isn't there right now, and we're doing this from scratch. So we're just putting our 5 dots in, and then we're gonna draw in all the lines that go with it. Okay, now we need to find the lower quartile. Look up here before you start this, because I'm gonna give you a couple of hints. The lower quartile is the median of the lower half. When we have a box and whisker plot where we land exactly on one number for the median, like we did here, okay? We're going to ignore that median. So we're going to ignore the 35, and we're going to find the median of the bottom half. Now, what gets tricky is I've already got numbers crossed out, so you have to be careful how you do this. When I do it, I make my slash marks go the other way. So instead of going from top right to bottom left, I'm going to go from top left to bottom right. So I'm going to cross them out, and they make X's. So cross these out. Here's my lower quartile at 20. Go ahead and do that on your paper. And then we're going to confirm, yep, that box at 20 is correct. So we're just going to kind of make sure that point is in the right spot. And our lower quartile was 20. And we're going to do the same thing with the upper quartile. Make your slash marks go the other way than they already have. So 38 and 90, 40 and 60. I'm landing on 48. And if I look up top, 48 is where that other point is. So our upper quartile is 48. Now we can take those 5 points, pretending I just put those 5 points up there. Now we can make my box and whiskers. So the middle 3 turn into our box with the line going through the median. And then we're going to connect our upper and lower extremes to make the whiskers. And it should look like that. Then we can finish answering the rest of these questions. What is the median distance traveled? That's the same thing as the median. We said that was 35. Number 7 says half of the commuters traveled between blank and blank. We've got a couple of different answers that could work here, okay? So the middle half of the commuters traveled between what and what?
5 and 40.
The middle 50%. 20 and 48. So that's the middle 50%. What if it was the bottom 50%? What would I say the bottom 50% were between 5 and?
20.
No.
5 and 35.
5 and 35. So remember, each section represents 25%. So if I'm looking at 25% for each of these, I'm looking for 2 sections. So that's 5 to 35, the median. What if I wanted the upper half of the data? The upper 50% traveled between, Anaya? 35 and 90. So any of those combinations would have worked there. And the last question, what is the interquartile range? So that's the upper quartile minus the lower quartile. Gus?
28.
28. We got that by doing 48 minus 20. Okay, so that paper is done, but it is a really good paper that has notes and has an example and a step-by-step for you. I'm going to show you one more real quick, and then the rest of the time is yours to work on homework. So look at this one before I flip to the next slide. Does everyone see how on this one we landed exactly on one, exactly on one number in the middle for the median? Okay, I'm going to show you what happens when it's different, when we land on 2 numbers in the middle and we have to find the median with those 2. So, I need to put these in order. 2, 4, 6, 8, 10, 12, 14, 15. Yeah. Okay, I'm going to cross off, hang on. 2, 6, 8, 10, 12, 14. I'm going to pretend this data point isn't here because I want an even number of data points. So let's put these in order first. We've got 18. Help me out here. 27. 34. No, nothing in the 40s. 52, 54.
68, 59. 87.
78.
85.
82.
82. We want them in order, guys. Look at all the numbers. 85. Perfect. Yep. Say them all at the same time. That's super helpful. Okay. So we've got an even number of data points here, 14. I crossed out the 15th so that it would work out this way. I'm going to start the same way. I would put my dots on 18 and I would put a dot on 98. Then I would find my median. So I'm going to cross out 18 and 98, 27 and 93, 34 and 91. Keep going. Okay. I end up with 68 and 78 in the middle. Okay, so to get my median, I need to add these two together and divide by 2. Let's start there. 68 plus 78 divided by 2 is 73. Good. Okay, so my median is 73. Look at how this process changes now, though, when I'm finding my upper and lower quartile. Since I didn't end exactly on one number in the middle, when I go to do my lower quartile, I'm going to do my median of this whole range here. So I'm going to include the 68 in the bottom half, and I'm going to include the 78 in my top half. Okay? So I'm going to cross out here 18 and 68, 27 and 59, 34 and 54. My lower quartile would be 52. And then same thing, that 78 gets grouped up here. My upper quartile would be 87. So do you see how that changes just slightly when I don't land on one number exactly? Okay, so keep that in mind as you're doing this.